Hi guys, welcome to today's lesson on exact values with trigonometry. As you can see um, already on the screen here, the values that we'll be finding. We'll be finding a variation of sin, cos and tan of the 30-degree angle, the 60-degree angle, and the 45-degree angle. Now some people like to remember these just from memory. However, I use a triangle method to help me remember because I find that difficult. Okay, now first of all, what is an exact value? Well, if you grab your calculator out and you typed in cos 30 equals, now obviously your calculator will be able to find you that value. However, it will be a decimal place, and for most calculators out there, they won't put it as a fraction or as I guess an exact value. So we want to come up with a method that we can actually write down the exact values instead of using like the decimals. So we're going to use, as I said, a method I call the triangle method. So I'm going to start off by doing the first triangle, looking at, and I know mine is not accurate, so I apologize, but I'm going to draw an equilateral triangle of length 2 sides, two units. Okay, why have I chosen an equilateral triangle? Well, hopefully you'll remember that for an equilateral triangle, that the angles are all equal, which means that they're all 60 degrees. Okay. Now I haven't put the top one there because I'm going to actually do something. I've automatically, you can see got 60 degrees in there already. That counts for those ones. But if I now put a line in the middle and halve that triangle, what you actually will see that this little angle in here becomes the 30 degrees because it's halfway. So all of a sudden I've got this triangle here with the 60 degrees in there and the 30 degrees in there. So you can start seeing what I'm doing, because I'll basically want to create a right angled triangle with those lengths. Now I'm going to redraw this triangle, so please bear with me, just so I've got the half of it, just so it's a little bit clearer for you to see. Okay, so I've got there, as we said, there's 60 degrees, got a little 30 degrees up there, got my right angle. That length is 2 units. Now, we said here that there are lengths of 2 for an equilateral triangle because all sides are equal, but we cut it in half. So what's half of 2? Well, it's 1. And then for my last side, using Pythagoras' theorem, we can say that 2 squared subtract 1 squared equals that side squared. So 2 squared is 4, 1 squared is 1, so 4 take away 1 is 3, and remember, to get our answer, we square root it. We want the exact value, so there's no point of obviously finding the calculated version, I guess, of root 3. Okay, so the whole idea I've done that is now that I have a triangle with all sides, all angles, and I can now put some values for the sin cos tan 30, sin cos tan 60. But what about the sin 45? Okay, well, I'm going to do a similar thing. Draw another triangle. This time I'm going to do an isosceles triangle of sides 1. Now, if that's an isosceles right angled triangle, well then these two angles here must be equal because it's an isosceles, so they both have to be 45 degrees, and then look, that's where the 45s come from. Using Pythagoras again, we've got 1 squared plus 1 squared, well that's 1 plus 1 is 2, and square it my answer using Pythagoras' theorem. So all I've simply looked at to start off with is how to get the triangles that my values are now going to come from. So let's put some values in. Sin 30, well that's on this triangle. I've got my 30. Sin, well that's our SOHCAHTOA rule. So it's so opposite over hypotenuse. So it's 1 over 2. Gave my exact value. Cos 30 this time, adjacent over hypotenuse. Well, that's root 3 over 2. And tan 30 is opposite over adjacent, so it's 1 over root 3. Look at that, nice and simply, I've got my 3 exact values for there. Let's do sin 60. So now we're changing angles, now we're using 60 degrees. So sin is opposite over hypotenuse, so root 3 over 2. So root 3 over 2. Cos 60 is adjacent over hypotenuse, so 1 over 2. And tan 60 is root 3 over 1, or simply just root 3 because it's opposite over adjacent. We can just write it as root 3. And the very last one, we have to use a second triangle that we created. So sin 45, now because they're both 45, doesn't matter which angle you start with, I'm going to do this one here. So sin 45, opposite over hypotenuse is 1 over root 2. For cos 45, adjacent over hypotenuse, so 1 over root 2. And then tan 45 is 1 over 1, which is just equaling to 1. Okay, so you can see where my exact values have come from. Now, some people who've got a good memory or a photographic memory will just draw this as a table and they'll remember these values off by heart. As I said, I find that challenging, so what I do is I like to draw these little triangles that I can then read my SOHCAHTOA values off. Okay, if you can't remember that little triangle there, that first one we did, you can draw the whole big triangle out and then just halve it and halve the length, etc., and then use the Pythagoras theorem to sort the other sides. Okay, look, have a couple of goes at doing this yourself without looking. You know, write the sin, cos, tan, 30, 60, and 45s out without the values written there. Try to draw your own triangles and then keep on redoing that, and hopefully you'll get the hang of it. You'll start remembering how to find these values. Okay, I hope this was beneficial, guys. Once again, any questions, please don't hesitate to ask.